Copernicus was an interesting man, much like that crocodile killed the other day. Copernicus was born in 1473 in Poland. He formulated his heliocentric theorem with complete mathematical detail. This was a step beyond Ptolemy, who proved the Earth as the center of the universe using only religious proof.
Thousands of years ago, people believed that the Earth was at the center of the universe. However, Copernicus came and said that the Earth revolved around the Sun.
Copernicus was right, because the Sun was the center of the solar system. He observed the movements of the planets, especially of Earth. That's how he got his conclusion.
He had an observation tower built on the wall surrounding the cathedral he worked in. He had objects such as quadrants, astrolabe, and triquetra, and other objects similar to those of that time. Telescopes had not yet been invented.
Some of his most important findings were the elliptical cycle of the planets and the order in which they were. Another note, the orbital plane of the Earth is 23.5 degrees. That was another important finding by Copernicus, along with its rotation.
Though some ideas were wrong, he discovered many important facts which are impressive considering his technology.
Here is a model of our system. He noticed how all the planets revolve around the Sun. Later, his studies will lead to one of the most fundamental theories in humanity, relativity.
Isaac Newton was born in 1643. He explained mechanisms of motion. He was a priest and learned Aristotelian astronomy of the day.
Isaac Newton explained the fundamental law of gravity, the first law of inertia, and the second law of force. For example, if you have an apple that has a mass of
30 kilograms.
that's through an acceleration of
30
30 miles
kilometers
per second squared,
This will be 900 newtons.
Galileo was a man that worked professionally both in astronomy as well as in mathematics. However, his work in astronomy led him to a lot of trouble with the church.
Aristotle has stated that the velocity at which an object falls depends on its weight.
In front of thousands of Italians, Galileo proved that the velocity of a falling object doesn't depend on its weight.
Objects will fall at the same time.
He said that infinity describes the size of a collection. In Galileo's paradox, if you square the counting numbers, you get a one-to-one relationship. Each number has one corresponding value, and it doesn't matter how big the numbers are, still there's gonna be a one-to-one relationship. Let's try with another set of numbers. So as you can see, it didn't change. There's still a one-to-one relationship. All sets of values will have another values that corresponds to it. Galileo used this one-to-one relationship to describe infinity.
Descartes was a French intellectual of the Enlightenment period. He was a brilliant man not only in philosophy but also in mathematics. He developed various rules and worked much with polynomials.
Descartes made astonishing findings. Let me show you here the standard polynomial form a x squared plus bx plus c. Well, now, he developed the superscript to represent the exponent, and also he developed the law of the signs, which states that plus times negative equals negative, plus times plus equals plus, and negative times negative equals plus. That's plus.
Descartes moved to Stockholm to tutor Queen Elizabeth.
She demanded to begin work at 5 in the morning. The harsh climate and conditions became ill effects. He died later in 1650 with pneumonia.